In this session, we're going to look at lessons 96, 97, and 98. In lesson 96, we're going to look at the area of a triangle. This is a new way to solve for the area of a triangle. Area of a triangle equals half, two sides, half times two sides, times the sine of the angle in between them. So if we look at this, if we will find this angle right here, we'll call it x degrees, and we can plug in 12 and 10 here, the angle here, and we'll be able to find the area of this triangle. First thing we'll do is we'll start out with the law of sines in order to find this angle, because that is opposite the 10 and that is opposite the 12. So we have 12 over the sine of 70 equals 10 over the sine of A. So we get 12 sine A equals 10 sine 70 divided by 12. Divide both sides by 12. So we get the sine of A equals, it equals 0.783. I'm going to leave that in the calculator window in order to have the most exact. And then we get the second function of sine of that answer. When you do that, I get 51. A is 51.54 degrees. 51.54 degrees. Add that to 70, subtract from 180, you get 58.46. We can put that into our formula. So area equals half of B times C, 12 times 10. Put that whole thing in your calculator, you get the area is 51.14 centimeters squared. Not too tough, different way of finding area of the triangle. In lesson 97, we're going to look at what is called the ambiguous case. And it just basically means we're going to do actually quite a bit of thinking here as we go through this. So what we're going to do is we're going to look at different things, like if A equals H, then we have a right triangle. If A is greater than H, we have no triangle. If A is greater than H but less than the biggest side, we have two triangles possible. If A is greater than H and greater than the biggest side, only one triangle is possible. So what we're going to do is they gave us this right here. And we drew a triangle. We don't know what kind of triangle it is, and that's what we're trying to figure out. We're going to put 9 here, kind of what looks like the hypotenuse. We have 40 degrees, and then opposite the 40 degrees, we're going to put A and H. And so we're going to use a sine problem. We're just going to say sine of 40 degrees equals opposite over 9. Almost as if 9 is the hypotenuse. And we'll multiply both sides by 9, and so what we'll do, we'll hit 9 sine 40. When we hit 9 sine 40, we get 5.785. So it's not equal to 4. It is not less than 4. It is greater than 4, but it is less than the biggest side. So we have two triangle possibilities here. And the two triangle possibilities that we have are, we either have an obtuse triangle, which looks something like this, or we have an acute triangle. These are the only two possibilities that it is. It's not a no triangle, it's not a right triangle, and it's not the last type. It's one of those two. Strike that, I read that wrong. It is not those. If you will notice, I said that wrong. A is less than H, so it is no triangle. Here's another type of these. We get sine of 27 equals H over 7. Multiply both sides by 7. Whenever you do that, we're going to get H is 3.18. So A is not equal to that. A is not less than that. A is greater than that, but it is less than that. So, it's two possibilities. We actually need to solve for both of these possibilities. So let's draw the two possibilities. We have the obtuse, and we have the acute. So we're not really sure what our angle is here yet. So in these two possibilities, we have 7, 5C, 7, 5C, and we have angle 27 degrees here. And so we will use the law of sines to solve for our missing angles. So we'll go 7 over sine of x equals 5 over sine of 27. So we get sine x, 5 sine x equals 7 sine 27. Divide both sides by 5. We get sine x equals 0.635. Then when you use second function sine, we're going to get x is 39.46. Clearly, the obtuse angle is not 39.46. So this will work for our acute angle. But for our obtuse angle, you subtract this from 180 and we get 140.54. Then from there you can solve for all the missing pieces like it wants. You guys know how to do that. We're going to do some more on logarithms in lesson 98a. When we have log 5 to the 15, we'll add a y in here. We'll go y log 5 15 in order to solve for this. So it'll be 5 to the y power equals 15. And then from here, we'll bring the y down. And we'll say y log 5 equals log 15. Divide both sides by log 5. So y equals log 15 divided by log 5. So y equals, when you put log 15 and log 5 in your calculator, you get 1.1761. Put the other one in your calculator, it's divided by, it'll be 0.69897. So therefore y is going to equal 1.6826. Therefore log 515 equals 1.6826. Not too tough, just uses some of the things that you've learned about logarithms in order to solve for it. One last type here. You get something like this. This is actually squaring the log x, so that means you write it twice. Log x, log x. This, the 2 can come to the front, so it has 2 log x. Divide both sides by log x. Get rid of one of the log x's over here, so now you have 2 log x. Remember, this is actually base 10. So you get 10 squared equals x. When you go to exponential form, we know that 10 squared is 100, so your answer is x equals 100. All this is using your knowledge of logarithms in order to kind of take it to the next level. That's it for lessons 96, 97, 98.